Hello everyone, my name is Hani Raza and my group partner's name is Advait Samant. We are the final year students of the Information Technology Department, mentors of Malik Urade from the IT department, and this is a project topic, automatic and specific image tagging using machine learning techniques. This is basically a project internship given to us by Prosaris Private Limited company. This company basically is an advertisement company, and now the reason why they have assigned us this project is that uh, this Prosaris company has a repository of thousands of images, and each they have enough. That means that they have more than enough resources to reuse on a new project. Like they don't need to again go through the efforts of constructing or like shooting new images or construct new designs. They can already use few images from their repository, which already consists of thousands of images. But the issue comes that how can they retrieve it, how can they use those images, how can they retrieve it basically. So the reason is that retrieval is not easy because the images have not been properly classified and hence not properly indexed while storing them. So it's that's the main concern. This is the main topic, this is the main reason why they have assigned us this project. That's the main target we are trying to achieve, that is classifying the image um, automatically using machine learning techniques. And we aim at as you will see ahead, our target was to specify the gender, the age, expressions, emotion recognition, and various other things, like to basically classify the image as much details as we could, so that it can be properly so through its captions it can be properly classified. Yeah, the scope is to dive into machine learning algorithms for image recognition, to use machine learning for auto recognition, classification of the company's image repository. Now, basically, the steps. First, we're supposed to first for an image, we're supposed to pre-process it, and after pre-processing, we just use machine learning algorithms like CNN basically, and we assign various tags to it, I mean descriptions to it, and then after that, after it's properly classified, then one has to like find the proper algorithm to index those classified images, so that it can be searched later on, for it can be easily retrieved. Technology stack, like we have used Python and like various libraries, Keras, TensorFlow, NumPy, Pandas, Matplotlib. And we have used NLP libraries for captioning, and of course we have used convolutional and neural networks. Now first, like you can see, first we have to detect the objects. After we have detected most of the objects of the image, we are supposed to tag them and their features to efficiently describe the image. That's the target. So, for instance, this is how it should look. You can see a man is standing here. There's a written train, and the confidence is 99%. Like confidence level is the probability of it being true. Like we need tags like this. So now what we've achieved. So as you can see, we've achieved this multiple object detection. I'll go module wise what we've achieved, and in the end, we're supposed to integrate these modules. Now this is now multiple object detection. You can see there are three zebras and all there are three boxes. There's written zebra is a detect object has been detected, and there's a probability value 99.863, which is like a high probability value that it is zebra. Similarly, there are multiple cars and they have been detected accurately too. Now this is class activation function thematic maps. So this basically shows the value, the knowledge that can be gained from the subsequent layers. Like the CNN layers have a lot of value, the layers have a lot of value to concentrate on these regions, that is the darker shades. As they go away from the center, it becomes lighter because the knowledge has reduced there. It will not affect much in the changes, it will not have any much effect on the weights parameters, hyperparameters. So this is a elephant, this is a buffalo. And now next we go on to facial feature recognition. We have used transfer learning here to make it as accurate as possible. Google's weights. You can see here we've accurately like classified. You can see the eyes. These are the nose. These are the mouths. Now facial recognition. Now you can see here, this is my partner's image, and we've verified it, comparing it to mine, and it's not me, so it's not received authorization, so it's false. This is the value. Basically, here we used inner dot product to compare the value. If it's greater than threshold, we just say it's true. If it's less than the threshold value, it's false. Just it's basically the cosine between the two values of the face values. This is similar as done here too. Now this is the age and gender specification. Yeah, you can see here appropriate age and gender has been specified. Here is done for the multiple people, and now here we have implemented emotion recognition. My this is my face, which is neutral, and this is his my partner's face, which you can see is happy, properly recognized. The emotion is properly recognized. Now here we have implemented captioning, so you can see a man is standing in the dirt with a frisbee. We've seen this dirt. It's recognized the dirt, it's recognized man and the frisbee. There are two cattle are standing by the side of the road. As of now, we are not able to classify. We are not able to go into much depth into describing animals, but still, it can be done later on as a future extended scope. Similarly, here this is a funny photo where it's written her bike trying to on her bike trying to race the bus. On it's written her, so we can assume it's a woman. It's understood that it's a woman. Here, a picture of bathroom with an open door. So, as I said, the proposed next steps are integrating the different modules implemented and ensure that image is tagged as anticipated. Now, next we are supposed to after classifying the image, we are supposed to make sure that it's properly indexed and so that it can be stored, and then when as per the requirement can be retrieved easily. So, and if a very efficient algorithm should be chosen. And the two models are supposed to be flexible enough to accommodate any possible improvements, which we have made sure, because it's transfer learning, so you can easily update it if any better model comes. And now increasing efficiency in the different algorithms implemented, yeah, it can be done still as this transfer learning. Now let's have a look at the code. First, we thought before going into the depths before implementing, let's see how this CNN works and how do the internal layers process the various images. So basically, we're just installing here Keras, NumPy, Keras, and TensorFlow and all. These are the different classes of images. You can see. Now we will be using now we are convolving, then using activation function. Then we are using pooling, and then we are using it again and again to improve it. And then you can see in the end here, this is confusion matrix. Yeah. You can see this is the first activation layer. This is how the filters look. You cannot see much about it because it didn't capture much of any knowledge from the image. And now as we go on in the depth of layers, we can see it has captured much and much. It is increased, the amount of knowledge gathered is increasing. This is the last layer, and you can see you can clearly identify a shape over here. The image may not be that clear, but it has identified a boundary shape of the animal. This is the dog. So now let's go to the object detection code. As I already showed you this zebra image. Here this is the code. Here this is just the mathematics basically to define the boxes. We've defined the labels, possible labels for the images, and now the boxes have appeared after implementing them. Similarly for cars. This is for face verification, for detecting the facial features. Because we've installed the multitask CNN library here. We've used this is a simple one. We've just imported an image and implemented the module over it. So you can see these are the parameters, facial parameters. Now this is the box, and now you can see these are the parameters: eyes, nose, mouth. They have been highlighted. Now face verification. We've installed Keras special libraries, even empty CNN, and now we are implementing it here. Basically, as I said, it is a cosine value between the value of the image, which is like it's my image and my partner's image. So it will be just finding the difference between it. If it's less than, we have defined the threshold to be 0.5. If it's less than 0.5, then it's false. We assumed it to be 0.5 threshold value. That is basically, if the score is 1, that is the cosine value is 1, that is the image is same, ideal case. But it's not possible for it to be exactly 1. Now age. This is the code for age and gender. Like I said, we have import. We use transfer learning here. We can even use the webcam available on the laptop for choosing an image. But we've imported an image here. You can see the output is there. Now this is for emotion recognition. We define the class labels. Now you can see the emotion is neutral. Now this is the final module, the computer vision captions. Now we've imported NLP libraries in here too. We have defined the model here, caption solving. And now this is just a graph minimizing, showing how with iterations the errors are minimized. And now we've imported these are links to the images that I've shown in the PPT. You can see we've got the captions. So as discussed in the PPT, the next steps would be integrating these modules and hence finding appropriate algorithm for indexing them images so that they can be retrieved efficiently when required. Thank you.